Okay, here we have the question. This is from 2022 NEET paper. So what is happening here? A cell of mass m is at rest initially, and it explodes into three fragments having mass in the ratio 2:1. So we can take the masses of these fragments, let's say 2m prime, and then second one has mass 2m prime, and the third one should have m prime. Okay, and summing these all should give us m. So leave it for now. Let's if it is necessary, we can take this thing into account. But okay, if the fragments having equal mass fly off along mutually perpendicular direction with speed v, then we have to find the speed of third fragment. So what is happening here? Initially, this cell of mass m is at rest. It means if we are considering the cell to be a system, the initial momentum of this system is zero, as it is at rest initially. And now what is happening? It explodes into three fragments. So this cell is exploding, means something happening within the cell or within the system. There is no external agency or external factor working on it or applying any kind of force. So if there is no net force, the linear momentum should be conserved. Means the final momentum of this system should be zero. And now, in case of final system, what is happening? This cell gets fragmented into three pieces, and these three pieces are moving along some directions. So if the fragments having equal mass fly off along mutually perpendicular direction with a speed v, let me draw the diagram for this. Okay, so these two fragments having equal mass, they are moving perpendicular to each other with a speed v. This angle is 90 degree, and I have taken here the coordinate system for reference to make the things easier. So these two fragments are moving with some speed v, and now we have to calculate the speed of third or lighter element. So coming back to this diagram, the final momentum should be zero, and final momentum. Let's take the final momentum of each of the constituent, and let's resolve it into components along x direction and y direction. So in this case, 2m prime. Okay, this angle we can take this angle to be 45 degree and this angle to be 45 degree. How can we take? Because look, we are free to draw our reference frame. So when this mass was initially at rest, we are choosing that point to be origin, and then we are taking coordinate system such that these two fragments which are moving with right angle, making right angle with each other, their motion. So we can take this x-axis such that these two fragments will make 45 degree with, okay, with this x-axis. So now it's time to resolve the components of this momentum. So along this direction, due to this fragment, the momentum will be 2m prime v, and component of this thing, that should be cos 45 degree. And of course, it has another component of its momentum along this direction, and this should also be 2m prime v sine 45. Now coming to this fragment, this one has momentum along this x-axis, actually negative x-axis, 2m prime v cos 45 degree. And of course, it has along negative y-axis 2m prime v sine 45 degree. Now, what is happening? These two components are equal in magnitude but opposite in direction. So, along y-axis, it has total final momentum 0. So, final momentum of this system along y-axis, if we are taking along this direction positive, so we have to take along this direction to be negative, and then we can sum these two things to get 0. But along x-axis, it is final momentum along x-axis, it is 4 m prime v cos 45 degree. And now there is third fragment, and this third fragment should move just opposite to this direction. Okay, what is happening here? At the end, if we are collecting all the components of momenta of these fragments, net momentum should be 0. So if we are taking these two fragments, they have net momentum 0 along y-axis, but they are giving some value of momentum along x-axis, actually negative x-axis. And this value is 4 m prime v cos 45 degree. So momentum of this third fragment should be equal to 4 m prime v cos 45 degree, but it should be along the positive x-axis, equal in magnitude but opposite in direction, so that after collecting all these things, the net momentum tend to 0 or equal to 0. So the momentum of this final third particle or third fragment should be 4 m prime v cos 45 degree. Okay, uh, let me add another slide. So its mass is m prime. Let's say its velocity is v1. So m prime into v1 should be 4 m prime v cos 45 degree. And then v1 should be 4 v cos 45 is 1 by root 2, and that will give 2 root 2 into v.